Hello, friends. Good evening and welcome to Eastern Academy. We are discussing about controller programming, and it's a session 6. And this is another very important controller. And these are all the very essential controllers. That important, I can say that timer, interrupt, like this one. This one is a DMA controller. These are all very essential on a system nowadays. You'll be very surprised about what is DMA controller does. It does very simple task. It does very simple task. What is the task? If I write it on software, that task you will understand what it does, what DMA does. If I write a program, let us assume that char star source star destination size. So int size. Assume. Am I right? Now, if I write a program for I is equal to 0 or size, size less than 100, size plus. Okay, sorry, before that we write one thing. Source is equal to 0x 1000. Destination is equal to 0x 2000. Then we write here for size is equal to 0, size less than or I is equal to 0. For I is equal to 0, I less than size I plus. I write here star destination plus equal to star source plus. What it means? If we expand this, the meaning is star x is equal to a is equal to, let's assume that a is equal to, let's say CHRA or temp. Temp is equal to star source. You are reading from the source. Source is what? 1000. So it means that you are reading from 1000. 55. The 55 comes to temp. Then you say star destination equal to how much? Temp. That is, you are writing the 55 to now 2000. So because destination is 2000. Now you say source plus. Destination plus. Now source become what? 1001. Destination become 2001. Now you go back. If you go back, so it will do once again from 2001, maybe 10. It goes here. Till what? I'm copying up to the size. Size is 100. So I am copying a block of memory. From this to this. This can be written as a function. I remove all of them. I say that void, assuming void, I don't return anything. Mem copy. Then char star source, char star destination, int size. And this function, I'll say int I, because I declare only that. See that? So I have a function called memcopy. So my microprocessor execute this software and read line by line and storing it on line by line. So I'm copying a memory copy. This is SRC means source. DST means destination. Understand now? Now, the problem is when I execute this in the microprocessor, when I execute this memcopy in the microprocessor has to read the instruction. The microprocessor has to read the instruction from memory. Then first instruction. Then it has to read from memory and write into the memory. This all takes more time. Also, this microprocessor can do some other work that time. So what people engineers did a one good thing. They made a microprocessor and there's a memory. And there is something called a controller. This guy will copy from this block to this block. From 1000 to 2000, 100 bytes. You tell him he has three registers. Source, destination, and size. You write here 1000, 2000, and 100. Then you tell him start. Then he will do that. That time you are free to do the work. Like exactly like this. Let us assume that I have a notebook. I want to copy page number 100 to 200 to 500. I want to copy from 100 to 200 to page number 500. I want to copy in the notebook. If I start doing the copying, I will waste a lot of my important time. So I appoint a document assistant, called document or document copier. I appoint a document copier. I told the document copier, hey, from 100 pages to 500. See that? From 100 to 500, how many pages? 100 pages. That's it. This goes there and it's getting copied. Is it clear? So I have appointed document copier now. Yeah, they don't need, but actually, even though you say it's not required, it's not possible. It's because the microprocessor can do only write or read. You understand? Microprocessor cannot do, I have only one set of data lines. I cannot write and read simultaneously. Okay, it is not possible. Microprocessor cannot do what? Read and write simultaneously. It has to store it on a temporary register. So I read and store. See, both are same. I'm writing here temp equal to star DST. Sorry, source star DST is equal to temp. Am I right? This is also same. If you write like this, star DST equal to star source. This is also same. Am I right? Both are same. When the compiler compiles, so this is not possible. I cannot do read and write simultaneously. I have to read first and put it on temp, then I have to store. But you don't see it here. That's the only trick. That doesn't mean that it is not happening. It's all happening on the background. Now, there's a problem. I have a notebook. I told the document copier, hey, you copy from 100 to 500, 100 pages. I told him. What the document copier will do next? Tell me now. What the document copier will do next? He will ask me to give me the notebook. The document copier will ask for the notebook. If I don't give the notebook, he cannot copy. Am I right? Same thing here. Now what happened? This memory right now is owned by who? Microprocessor, writing data and reading. Now you ask the controller to copy here. Then what the controller will do immediately, he will send you a signal. Call request. What request? Hey, give me this one. Memory. Give me the memory. Okay, 1 minute. Okay, so this was the trick. The trick here is we ask the controller to copy. Okay, but the control you told him to copy from 1000 to 2000, 100 locations, but you didn't give the notebook. You didn't give a memory to him. So he has given a request. Then what this guy will do, the microprocessor, he will put the switch off internally. That means that he will release a notebook and he will tell him who that controller acknowledgement. Take it. He give 5 volt. This guy give it back. Yeah, you take the notebook. What this guy will do now? He will use the address line and data line and read and copy. Everything will be done by this guy. The microprocessor will idle that time. Microprocessor will be idle. Understand? Understand? No, microprocessor is idle. Whereas the copy is done by this controller. After copying is over, after copy the 100 pages, this controller will tell him, hey, I completed by giving 0 volt. So no more request is there. Then the acknowledgement will make it as a 0 volt, telling him that, hey, I have accepted. That means that this guy will become the controller. This guy put off. Normally this guy will be off. This guy will be using the memory. Whenever you are requesting him to copy, he will do that. So this is the way this works. Understand? I'll draw the diagram now. Now you understand. I have a processor. This microprocessor having a memory. And there is a controller. This microprocessor tells the controller, hey, from 2000 to destination 5000, you copy 1000 pages, 1000 locations, size, 1000 bytes. Then you will say start. The moment, these are all 2 registers. You write into register. Once you write to register, the controller, once you say start, then the controller will give a signal called request, 5 volt. The moment microprocessor get the 5 volt, he will switch off himself from the memory. He will not be now contacting the memory. He is disconnected. So now this memory is not owned by microprocessor and not controller. Now the microprocessor will give a signal called acknowledgement by giving 5 volt. Now the controller knows that, hey, this is a bus. I have to do that. So what happened? He will put the switch on and start doing the activity with the memory. Now he became the master of memory. Please understand, when the microprocessor is writing in the controller, microprocessor is a master and the controller is a slave. But when I am trying to copy the memory, the controller become master and this become a slave memory. Once he complete the 1000 bytes copy, then he will make the switch off. He will get out of the memory. Then make the request 0 volt, telling the microprocessor, hey, I have released. Now, what the microprocessor will do, making the acknowledgement 0 volt, telling him that, hey, thank you. This is a thanks, I have done it. Then put this guy on, he will start continuing. But understand one thing, all your instructions are there in the memory. Now, when this guy is off, the microprocessor cannot get the even instruction. So this guy is in the ideal mode. He will not execute things when the DMA controller is doing the activity. So there's a big difference between interrupt controller and this controller. This is called DMA. DMA, that's called direct memory access. Direct memory access. Direct memory access. Is it clear?
Sir, what is the use of DMA and application? Where will you?
Yeah, now I'm going to tell you that. Now I'm going to tell you the application. Thanks. That's what exactly. Now, what is happening is this. For example, I have a microprocessor. I have a hard disk. And I have a hard disk controller and my memory. The memory you have typed some data. You have application notepad. You're using a notepad. The notepad, you type some data, some text, some letter. That letter will be stored in the RAM. The RAM. You understand? The letter will be stored in the RAM. Now, if you power off the machine, this is volatile. This is volatile. This will be gone. So you will give a command called save. You will do the save command. When you give a save command, this from the memory, this file will be stored in the hard disk permanently in a sector. Somewhere in the magnetic sector is stored. That you can see our, I think I have a video. I might have shared it to you, all the storage, how it works. You understand now. Now what happened? This guy is in the memory at location 2000. And this is 512 bytes. Normally a sector is 512 bytes, we assume. This is 512 bytes, but this assume is the 512 bytes. Now what the microprocessor will tell the DMA controller, sorry, HDC controller, my data is there at 2000 and 512 bytes. The hard disk is very, very slow. If a microprocessor start writing from here to here, it will take very long time. So there is a waste of two things. Waste of microprocessor time. Also, there is a waste of the memory budget time. That means that during that time, you are not using the memory. So when the moment you give a save command, what this microprocessor does, it tells this hard disk controller, hey, take from 2000 and 512 bytes. What this guy will do, that's a beauty. This guy is having internally 512 bytes RAM. Who? The hard disk controller. He will copy from here to here. Done. Now this is free. That means that this data is free now. I have copied to my local. Then he will release it to him. The microprocessor will start doing the operation. Now, this guy will slowly from here, either SATA or whatever interface, whatever it is, he will, from here, he will give to hard disk controller. Understand now? So, this is the place from your RAM to hard disk controller. For example, forget about hard disk controller. Let us say network controller. I want to send the data to the internet, through Ethernet or Wi-Fi via the wire. Now what happens? Our man copy this file from here to here and send it serially to Ethernet to the internet. Okay. It's clear. Where the DMA is used. The DMA is a powerful, now they have a built-in within the controller. The controller is having a built-in DMA, which it does from memory. So otherwise, what happens? Your microprocessor has to read from here and write it here. That takes a lot of time and waste of my time. Now you may say that when the microprocessor is, when the DMA controller is doing the activity, the microprocessor is idle. No, you know one thing what people do? Nowadays we have, to avoid that problem, we have a cache memory. We have a cache memory. Because of cache memory or cache memory, whatever it is, this guy will be executing the code from here itself. So nothing will waste to your RAM memory. So microprocessor will be doing working, you will be doing your activity. We have to understand about the cache later. Now you don't worry about cache. Cache is a temporary copy of your memory. The latest access memory will be stored here. So for example, if you're doing a for loop, for I is equal to 0, I less than 10,000, I plus plus, you do the activity. If you do this instruction, the main memory is slow. This cache memory is fast. First time it will read from here. That is called cache miss. But later, this program comes to the cache memory. This is actually DRAM. This is SRAM. Now what is happening? The cache memory, this guy will read from the cache and start executing things. That is called cache hit. During the time, you can use this RAM. This RAM can be used. Clear? Is it clear? Now I have explained that why we are using the DMA. DMA is called memcopy. That's called direct memory access. Every controller is having a built-in DMA nowadays. So they copy from main memory to locally and start doing it. Nowhere microprocessor comes into picture. You tell him that from where the data has to be sent to the internet. That is enough. That is done. Sorry. Sorry. Is it clear? This has to be understood very clearly. This is what the another important controller used nowadays. So if you know that DMA controller, you will know how the transactions are going on. This you will start getting into the advanced topics when you start doing Ethernet controller, this controller, that not you will start using DMA. Otherwise, normally we don't. When you're writing a small LED program or not, we don't use DMA controller. But knowing this thing is very important. So there are three. Understand one thing. First one is called polling. Let's summarize. So let you summarize everything. The first one is I have a block which is having a computer. The computer is nothing but I have a microprocessor, ROM, and RAM. This is what this computer. To make this computer to work, you should know C programming. This is essential. So this should be the first step. So please understand, your first step should be learning C programming. This is what you are embedded. The embedded is having a built-in computer. If you want to use the computer, you should be a good programmer. That's why C program. Then this is the first step. Second stage, it's a computer. We have an input. We have output. That is called embedded GPIO, general purpose GPIO programming. This is the second one. GPIO programming is the second stage. Please understand. This is what we practice LED, 7-segment, switch, and keypad, dot matrix. You thorough with that. You should not have a doubt on that at all. And how fast you do that. That's the trick. It's not doing is important. These are all skill. You should do fast. Do the same thing repeatedly. If you have done LED, go back after a week and do LED. If you've done 7-segment, go back after a week, do a 7-segment. Whenever you have a boring, you go and write the program what you know. Third one is you talk to the controllers. We talk to the controllers. This is called that when you talk to the controller, there are 3 methods. One method is you give a job to the controller and read him his status register. Find out whether you are completed or not. This is called polling. This is called polling. That means that I give a work to somebody, my employee, and repeatedly asking him that, have you done or not? Have you done or not? That is called polling. So to avoid the time, what people did was the controller case. This is a computer. What you have done was they have used the between your microprocessor and your controller. They have introduced interrupt. There's a second one, the interrupt controllers. And third task is DMA. I want to copy from memory. I do copy faster. He uses a signal called DMA request. And he gives a signal called DMA acknowledgement. You understand this? This is the third one. The third one is controller, embedded, controller programming. You can bypass all the step by using a function directly, but you will never understand any other thing. And the interviews also don't like that. The fourth one is you have a controller and you have a microcontroller or computer. The interface is through UART or I2C or SPI or this one. What do you call CAN? Any bus. Maybe latest very high speed means USB, PCA and everything. PCI Express, everything. You understand now this is a very top level. Please understand at top level. The level 1 is C programming. Without that, you should not go here. And without understanding this programming, don't go here. Everybody wanted to have a bypass. Fine, I don't mind. That is what your logic. As a doctor, I say that this is what you maintain. But you say, no, sir. I like to eat my medicine what I like. My friend has told me, my other doctor has told me, follow that. Nothing. As a industry 35 years, I am telling you that how to follow this. Now, fourth one is interface programming. Understand? So this four have to be understood very clear and start learning from 1, 2, 3, 4, everything, writing functions. You should start creating your own libraries from every time. That means that previously written program has to be reused by you. Otherwise, there's a problem. So this is all about, but the moment you understand the controller, the same thing here. This is different. Once the UART, I2C, SPI and CAN are used to see here like this. Please understand here. What is the difference? The first case, you have a microprocessor, you have a controller. The controller is having a register, has an address. You use the address bus and data bus to write to the register directly. You put star PTR, star out. Out is equal to 0x30. Star out is equal to 0x51. Now address 30, 51 is written. It's a direct access. But unfortunately, when I start using the microcontroller, the microprocessor address will not come out. It is not available outside. Then what you will do? Understand? Then what you will do? That's a problem. That time, people use buses, serial buses, I2C or SPI or CAN and UART to write into the register. But the functionality is same. There is no difference between the controller. Please don't get confused. There is no difference between the controller is same controllers. But how you access a register is different. In this case, you write directly. In this case, you access through the separate bus. So there is something called I2C controller. That guy will take from the microprocessor and through I2C you write into the register. This is called I2C controller. That guy converts to a parallel to serial data. That I can share all the previous classes I2C documents to you. No, it's not a thing. You can write your own .h file and include it. No, there's a big difference. They don't get confused. That I'll explain to you next week. What is the header file? What is library? I'll explain to you next week on the C class. There's a big difference. And this is called preprocessor. And this is called linking. In between, you have called compiling and assembling. There are two So this is a stage 1. This is a stage 4. Then 5th stage is loader. 6th stage is the executor. Okay. So this we'll discuss next week. That's this all next. I'll send you the next week schedule by today. End of today, I'll send you the thing on the group. And tomorrow morning, I'll send you that. I'll teach about what are the things on Mondays and Tuesdays. Okay, then I think DMA controller I fairly explained that. That is a controller, a memory, and there is a DMA controller. This guy gives you the signal called DMA request, and this guy gives a signal called DMA acknowledgement. Now, this guy normally, the microprocessor wants the memory. So microprocessor wants the memory internally a switch. Now this is also connected to the bus. Now this guy is off and this guy is on normally. When the DMA controller gives the request, the microprocessor disconnects itself from the memory and gives the acknowledgement. Once this guy gets the acknowledgement, now that DMA controller will own the memory. He will finish the transaction, then he will make the DMA request as 0, telling him that I completed the work. Then this guy, microprocessor, will give the ACK as 0. That means that, hey, you have done. I'm going to take back. Then he takes back. This guy become off. This is a very simple transaction. What the DMA controller does is mem copy. This will copy from memory to memory or memory to internal memory. That depends on how do you use it. So this is all about DMA controller. So we have discussed about timer, LCD, interrupt controller, and this one, DMA. Next week we want to discuss about ADC, DAC, and motor controller. That means PWM. Understand? So these two are pending actually. I should have completed this week, but since I took a break. So if you have any doubt, you can ask me now. So you got a good idea, but you may not have, unless you do practice, you don't get it fully. That's a drawback with these things. You have to practice a lot.